Okay, today's video lesson is on the nature of acids and bases. This is the introductory chapter to the topic of acid-base equilibrium. So in this video lesson, basically what I'm going to do is kind of define acids and bases and talk about the properties of acids and bases a little bit and kind of distinguish between strong and weak acids and bases to kind of set the stage for the remainder of this semester. So we're going to look at acids and bases. Now there are three functioning definitions of acids and bases, and students get a little confused with the differences and why we have the differences. The original started with Savant Arrhenius. And what he did was he said that acids have to have a hydrogen ion in them. So something like HCl. So when we dissolve this into water, what he said was it's the hydrogen ion that makes our solutions acidic. So this was Savant Arrhenius' definition of an acid. He said it was the act of putting a hydrogen ion in the solution. All right. He also said that the base nature was due to the hydroxide. So when we put a hydroxide into water, we get Na plus and OH minus, and it's the OH minus that makes our solution basic. Okay, so that was the original idea. Now it's not a bad model, and it works very well. But the problem with Savant's work is that it was just very limited, because bases are bitter. They turn litmus paper blue, and they react with acids and neutralize them, right? You should know the neutralization is that these two come together to make water, which neutralizes the acid property and the basic property if they're at the same concentration. We talked about this in the first semester, or first quarter. Anyway, so if we look at ammonia, ammonia is considered a base, but the problem is there's no hydroxide in there. And this was the issue. So Savant's his definition was good, but it just wasn't all-encompassing. It didn't cover all of the bases. So Bronsted and Lowry, two separate scientists, a Scandinavian and a English chemist, came up with these two definitions, actually, well, one definition together separately from each other. Anyway, that's why they get dual naming for this name. Anyway, the idea is that we have a base and we react that with something that would be considered an acid. Okay, so what the definition here is not about hydroxide. So what we're doing is we're dropping the hydroxide out of the definition. What happens is we form the ammonium ion and we get a chloride. So as a result of this, what happens is we say that this hydrogen ion is donated to the ammonia, or taken from the acid to the base. So our definition of an acid and a base is going to change here. So we say the acid is the one that lost the hydrogen, while the base is the one that accepted the hydrogen. So it's a transfer of hydrogen ions from one side to another. Okay, I'll kind of show you that with these reactions. Now, here's the idea that if this definition has to work up here. So if you notice that this is going to donate the hydrogen ion. Now, this isn't necessarily accepting a hydrogen ion, but it has the potential to do that. Okay, it has the potential to absorb a hydrogen ion, and when you put this in water, it will do that. And actually, when I put these two together, you can see what happens is that this will donate the hydrogen ion to the hydroxide, and therefore we can keep the definition working together, and it still makes sense. Okay, so what we find with the Bronsted-Lowry definition is that if you have an acid, you must have a base. Now I put these in quotes because I'm not very happy with the terms donates and accepts, because that sounds like the acid wants to donate or willingly give up the hydrogen ion. And we know from things like sodium, right? When you have a sodium with a valence electron, it's not going to want to give up that electron, right? We've talked about this before. Okay, sodiums actually are pulling electrons. Right? They're attracting electrons because it has a proton, it has a nucleus. But the electron actually goes to the chloride because chloride is better at pulling the electron. Okay, so remember we talked about better pulling electronegativity differences and stuff and electron affinities. Okay, that idea is the same thing I like to talk about here. The reason why this is considered a base and this is considered an acid is only this. This ammonia is better at pulling the hydrogen than the chloride. Right? We could think of this as pulling the hydrogen. You got two things trying to pull that hydrogen, the ammonia and the chloride, and they're both kind of battling for that hydrogen ion. And we're going to talk about that as we look at acid-base equilibria. Okay, so for now, I don't like the words donates and accepts, but it's what's in the terminology. It's just typically in here for Bronsted-Lowry. I like to think of the base as pulling and the acid as, it is pulling, but it's just not pulling as well as the base does. All right, and the last one is the Lewis. Now this isn't on the AP test much. I'm just going to talk about it really quick and then let you guys, do what you want with it. But if you're going on to organic, you're definitely going to want to know Lewis acids and bases. Okay, so there's a lone pair of electrons up here. What Lewis said, because this is the electron dude, right? The guy that was always focusing on electrons. Well, there's electrons here in my chloride as well. So what's going on, he said, is that it's not even so much that the ammonia is pulling it, but it's the ammonia's electrons that are pulling. They're going to pull electrons here, and that chloride is going to be pulling electrons. So what we find is that the base is the one that donates electrons to the acid. All right, so the hydrogen ion goes over here. We don't even think of this as the acid. We think of the hydrogen ion clearly as the acid because it's missing electrons. Okay, so I wouldn't worry too much about the Lewis definition. In AP and in chemistry classes, this is definitely the supreme ruling definition. So you want to keep this one in mind. Arrhenius is okay, but this is definitely the definition you want to keep working with day in and day out in this class. Okay.